Hello everyone, welcome to today's class. We'll be continuing with our topic of differential equation and we'll learn the formation of differential equation, means the equation of curve or any particular condition will be given to us and we are supposed to create differential equation out of it. Okay, let's see some questions. We'll have to follow one simple idea. Okay, I'll mention that in the question itself. Okay, that the number of arbitrary constants is equal to, as such we know its order, or basically number of times we have to differentiate. Differentiation required. In order to create this equation, we have to use this idea that how many arbitrary constants are there is the number of times we have to differentiate the equation to generate a differential equation. So let's look at this question. He's saying form a differential equation representing family of curves y equal to mx. Equation is given to us. Now you can see m is there now. Whatever alphabet or whatever constant is there, that's your arbitrary constant, though they have clearly specified this. But even if this is not mentioned, you should understand that m is arbitrary constant. So I'll say number of arbitrary constants 1. That means one time we have to differentiate this to get the equation. Let's generate equation. Let's differentiate this. So differentiation of y dy by dx, differentiation of mx, m is constant, so differentiation of x is 1. Okay, now this is not a differential equation, dy by dx equal to m is still here. So the task is to eliminate this m. Okay, now what you can do is you put this m in this equation, okay, the original equation. So what do you get? Y is equal to m is dy by dx into x. Now this is the differential equation, or what you can do if you really want to make it look like a differential equation, you get this thing on the left, y plus dy by dx into x, or write down x dy by dx is equal to 0. Now it looks like kind of a differential equation. You can use the notation of y dash also. Okay, from now onwards I'll be using the notation of dash. Okay, y minus x y dash equal to 0. It's easier to write like that. Okay, next question, let's see. Again, an equation is given to us. Okay, it's saying it is representing some family of curves. Again, don't worry about what is the meaning here. Overall, this is an equation and you have to create equations. Again, he's saying a and b are arbitrary constants. So how many arbitrary constants? 2. That means 2 times you have to differentiate and create the differential equation. So let's create first of all y dash. Y dash is equal to, what is the differentiation of a sin x plus b? It will be a cos x plus b. Then differentiate again, because 2 times you have to differentiate. So y double dash is again minus a sin x plus b. Okay, now you'll think like for the last question, what did we do? We replace the value of m. For this, we cannot directly replace the value of a and b because b is present inside sine. But if you look at very carefully, what is this a sin x plus b? What is this? This is y. So somehow I got the equation directly, that y dash double dash is equal to minus y, or you can write y double dash plus y equal to 0. That's your answer. Okay. All right. Let's see another example. All right. We have this question. He's saying form the differential equation representing family of ellipse. Again, don't worry about the family word. Point is, we have to write the equation of ellipse whose focus is on the x-axis. So basically now you require the basics of conic section. What is the general equation of ellipse? That is what you need. Whose focus is on x-axis. It's like this. Okay, focus is on x-axis. The equation was, you have to know this, okay, because you will be starting from this, x square by a square plus y square by b square is equal to 1. This time the question doesn't give you the equation, you have to know the equation of ellipses. Okay, so this is the equation of ellipse. Now we have equation. Again, a and b are arbitrary constants, so number of arbitrary constant is equal to 2. So we'll start by differentiating it one time. So let's differentiate the equation directly. So x square differentiation 2x upon a square, y square differentiation is 2y into y dash upon b square is equal to 1. Sorry, not 1. Constant differentiation is 0. Okay, the differentiation of constant is 0. Now in order to get another differentiation, because we have to differentiate this 2 times now, what we'll do is we'll differentiate, should we differentiate directly? We can, okay. But let's see one manipulation. Even if we differentiate it one more time, the problem is that a square and b square will be still in the denominator as a constants, and the task was to eliminate them. So look at this approach. This is slightly different, but this is the first time you'll be seeing this. So try to understand what is the purpose. The purpose was to eliminate a and b. First question we eliminated by putting the value. Second question, somehow it happened automatically. Look at this, how we do it by force here. 2x by a square is minus 2y dash by b square. This 2 cancels. Okay. So our equation is x by a square minus y dash by b square. Okay. Let's take b square here and get the x here. Interchange the position. So you'll get, and if you want, you can take the negative also on the other side. So minus b square by a square is equal to y dash upon x. Okay. What is the benefit of this? Now your right side, sorry, your left side, this is effectively a constant. And what is the differentiation of constant? 0. And what was our task? To eliminate them. So somehow this is becoming 0. So differentiate again both sides. Zero is equal to, now in order to do the differentiation, this is slightly tricky. First of all, there is u by v. Okay, so we have to differentiate using this u by v. So x square, then u dash v. So that means y dash differentiation minus differentiation of x into y dash. Okay, is equal to 0 is writing now. So I'm writing now 0 on the right. Okay. So this differentiation, first of all, x differentiation is 1, so minus 1 into y dash. In order to do this, again 2 things are being multiplied and you have to differentiate that. So you will use here again uv. Okay. So what is that? Differentiation of y, first y dash as it is plus, need more space, plus y as it is differentiation of y dash. Okay. Again I'm repeating, what have we done? We applied uv on this. First differentiation of y, that is y dash, into v as it is, that means y dash as it is, plus this time y as it is, and differentiation of y dash dash. Okay. So differentiation of y dash means, again that means we are differentiating 2 times, that is nothing but y double dash. So y double dash This is y dash, this is also y dash, both are y dash, so I can say this is y dash whole square minus y dash. Okay. I think we missed something. Did we? Let me check. Y dash, y double dash. This is looking good. Oh, denominator x square I forgot to write down. But although that won't make any difference, the reason being, if I take it on the other side, okay, this is our denominator x square is there. No? If we take this to the other side, it becomes 0, so it doesn't really matter. You got this as an equation. Now, I think that's it. This is your equation. This is y into y double dash, writing the double derivative first, then y dash whole square minus y dash is equal to 0. There is no x. Oh, x was as it is, no? Here it is x. We missed this. This whole thing will be multiplied by x. That is what we were missing. That's why I'm thinking, well, why was the equation coming only in y, not x? So I'll have to multiply now. First we'll multiply and then we'll see. So the equation is now multiply this, so x y dash whole square plus x y dash minus y dash is equal to 0. Okay, and if I write this in order, means double derivative first. Okay. So x y double dash plus x y dash whole square minus y dash is equal to 0. That's your differential equation. Okay. If you use the notation of dy by dx, it will be very complicated to differentiate u by this uv u by v. Okay. You can write the final answer as like this: d square y by dx square plus x dy by dx whole square minus y dy by dx is equal to 0. Okay, this is done. Okay, all right. That's your answer. Both of them, the last two steps, both are your answer. Now this time he is saying again, now again I told you that you will be requiring basics of conic section here. Okay, you should know equation of ellipse, circle, parabola. Okay, and sometimes you have to generate special conditions on this, like this question. He is saying find the differential of family of circles. So circle equation we know, touching x-axis at origin. So we should create an equation of a circle which is touching x-axis. If the circle is touching x-axis, this is the radius. What will be the coordinate of this center? Okay, usually the coordinate we take is h comma k. Okay, but I think I've discussed this concept in circles also. Okay, grade 11th conic section circles. Now the condition is, in order for this condition to happen, your height should be, the height of the center should be equal to r. That means k should be equal to r. Okay, that should be the condition. So what is the general equation of circle? X minus h whole square plus y minus k whole square is equal to r square. This is the general equation of circle, and the condition for it to be touching x-axis. Okay, he's saying touching x-axis at origin also. Okay, so I have to shift the circle. This is one of the possibility now. Okay, but still I think the variables gets reduced effectively. H comma k na. First thing that we see is that the height is still equal to the radius, so k should be r. Also this h comma k, this center lies on y-axis. Okay, if the center lies on y-axis, the coordinate should be, x coordinate should be 0. Okay, so actually this point is 0 comma r. So you have your general equation, put the value of h and k. So x minus 0 square plus y minus r square is equal to r square. Let's open it and get the equation. X square plus y square plus r square minus 2yr equal to r square. R square cancels. You get yourself first the equation, 2yr equal to 0. This is the equation. Now that you have the equation, you have to create differential equation. So first of all, look at how many constants are there. Arbitrary constant only r is there. So, okay, so number of arbitrary constants equals to 1. Okay, that means we have to differentiate only one time. Okay, all right. Now point is, how can we get, should we get the value of a? Let's differentiate directly. Let's see what happens. If something is required, we'll see accordingly. The differentiation of x square is, okay, now differentiating both sides. So differentiation of x square is 2x, y square is 2y, y dash minus 2 r y dash. Okay, r is constant, so we'll leave it equal to 0. I think we got the value of r from this. Now we can get the value of r. Take this to the other side. This is 2x plus 2y. Everything has 2 na, in it. Okay, 2y y dash is equal to 2r y dash. Get the y dash in the denominator. So 2x plus 2y y dash upon 2y dash, okay, is equal to r. What we can do is we can cancel this 2 by taking common. Okay, now we put the value of r in this equation. We got the value of r. We have learned this method that we can put the value of r in this equation. We got ourselves a differential equation. So the equation will become x square plus y square minus 2y, r is x plus y y dash upon y dash is equal to 0. Okay, that's your differential equation. Kind of weird looking. Okay, should we solve this? I think we can solve this. Let's solve it. We can simplify this. X square plus y square minus 2y. Let's split the denominator. This is x by y dash plus y into y dash upon y dash. So y dash cancels. Okay, equal to 0. Let's multiply this also. So x square plus y square minus 2xy upon y dash and plus 2, no, not plus 2, minus 2 into this. So minus 2y square equals to 0. So you get x square minus y square, no? Y square by 2y square, you have to deal with that. Minus 2xy. Let's take it on the other side. Let's take it here. 2xy upon y dash. I think you can generate it, you can write the equation like this also, or you can write the differential equation like this. You can take y dash here and get this x square y square in the denominator. So 2xy upon x square minus y square. Okay, this is also a way to represent differential equation. dy by dx is equal to something, some expression of x and y. Okay, that's your answer. All right, we have seen circles, we have seen ellipse. Let's see parabola also. Is saying form the differential equation representing parabola having vertex at origin along positive x-axis. So x-axis, y-axis, parabola along positive x-axis like this. Now point is, you should know what is the equation of this parabola. There are two forms, y square equal to 4ax, x square equal to 4ay. Which one is this? This is y square equal to 4ax. Whichever has the power 1 will be the axis on which the parabola will be drawn. It is drawn on x-axis. Okay. Interestingly, it has only one arbitrary constant a, and now we know that if there is one constant, we can always get the value and replace the value of a from the equation. So number of arbitrary constants equal to 1. So we have to differentiate one time. So differentiating both sides. One time we are differentiating. So 2y y dash is equal to 4a. This is not dash, this was power 1 I was representing. So 4a, that's it. We get the value of 4a. No, we'll put the value of 4a because like 4a is directly present now. So we'll replace this 4a directly. Okay. So 2y y dash is equal to sorry, not 2y y dash, that was equation was y square is equal to 4a is 2y y dash and into x. So slightly, if you want to cancel this y and y, so you get y is equal to 2x y dash, or y dash is equal to y by 2x. Again, depends on how the options are given, how the equation is given. Okay. Y minus 2x y dash equal to 0. This can be the representation, or y by 2x equal to y dash. This could be the representation. Okay. All right. Now that we have seen these questions, let's do few more questions based on these ideas only. Parabola, ellipse, this is done. Okay. Where is it? Differential equations. We are doing okay, let's look at the first question. Got it. This is the equation. You have to create differential equation out of it. How many arbitrary constants? Try to find that first. Okay, remember constants are like a, b, c, p, q, something like that. X and y are main variables. Okay, so let's differentiate it. So first of all, identify number of arbitrary constants, that is 2. So that means we have to differentiate 2 times to get the differential equation. One time let's differentiate. So differentiation of x is 1 by a plus y dash by b is equal to differentiation of 1 is 0. Now if we still differentiate this directly, this a will be eliminated because this will become 0, but b will still be here. So what we can do, we can do the pretty much same thing that we have done earlier also. Take this a and b on the other side, take this y dash as y dash by b is minus 1 by a. Okay, and write down y dash is equal to minus b by a, and now differentiate again. Okay, both sides. So now y double dash, constant differentiation is 0, and that's your equation. Okay, y double dash is 0. Okay. Next question. Again we have the equation. How many constants? Arbitrary constants. 2 times we have to differentiate. Okay, so let's differentiate one time. So 2y dash is equal to a is constant, let it be in multiplication. B square differentiation is 0 minus x square differentiation is 2x. So 2y dash is equal to minus 2ax. The second one variable is already eliminated. Now we have to eliminate a. The idea is, if constant alone is present, we can differentiate. So take this x in the denominator, 2y dash, cancel this 2 actually. So y dash upon x is equal to minus a. If we differentiate both sides, at least now a also will be eliminated, and now what you have to do, this is same thing as, I think pretty much same expression, y dash by x. Where was that? u by v, no, we did. Yeah, same expression, y dash by x, same thing will be done, and the same differentiation is there, so you'll get the same equation. Okay, I'm copying that. Instead of minus b square by a square, now you have minus a. So still the differentiation will be same. Okay, and you'll get the same equation as your answer. Xy y double dash plus xy dash whole square minus y dash equal to 0. Okay. So no point of solving the same thing over again. uv, be very careful with that. Next question. Y is equal to this. How many arbitrary constants? We'll say that 3 and 2 are not arbitrary constants because we can see their values. A and B are the arbitrary constants. So again, arbitrary constants are 2. 2 times we have to differentiate. Let's differentiate one time. Y is equal to e raised to power 3x. Differentiation will be same, e raised to power 3x. Just that ax, the coefficient of x will come in multiplication. In integration, it goes in division. In multiplication, it comes in multiplication. In differentiation, I mean. So this is a into 3. So 3a e raised to power 3x, and b e raised to power minus 2x, differentiation minus 2x, and minus 2 will come here. Okay. All right. Nothing got eliminated. Fine. What we can do? Y double dash again. If we differentiate it again, can we really do anything about this? Let's see. Let's generate first y double dash and then we'll see how to eliminate. Multiply this again. So 3, again same differentiation, 3 will again come down. So 9a e raised to power 3x minus plus 4 e raised to power 2x. Okay. Okay. Now how to get the problem is 9b, no? This is again negative 2, so plus 4b it will come, e raised to power minus 2x. This time we were not able to put the value of a and b or anything. We cannot separate them also, okay, because nothing 0 is created as such. All right, so what we can do, we'll have to put some values. Okay. let's take these two equations. Okay. First, this is second, this is third. Okay, what I am doing is solving 1 and 2. Now, this is also a sort of a different idea. So if we solve 1 and 2, y is equal to a e raised to power 3x plus b e raised to power minus 2x. This is y dash is equal to 3a e raised to power 2x minus 2b e raised to power minus 2x. Now what kind of solving I'm talking about? I'm talking about elimination. Okay, so what do? You multiply this by 2, 2, 2 and now add them. The moment we add them, these two cancels and we got 2y plus y dash as if we add them we get 5a e raised to power 3x. Okay, so we got the value of a raised to power 3x. 2y plus y dash is equal to 2y dash upon 5 basically is equal to a e raised to power 3x. Okay, that's what we have done. We found the value of a e raised to power 3x. Same way you do it again, this time doing the elimination on a raised to power x. Okay, so solving 1 and 2 again. So y is equal to 2a e raised to power 3x plus b e raised to power minus 2x. Y dash is 3a e raised to power 2x minus 2b e raised to power minus 2x. This time we are doing for the reverse. Last time we eliminated this b e raised to power 2x. Now we'll eliminate this a e raised to power 3x. So what I'll do is I'll multiply this by 3. First equation by 3. So 3, this will become 6, this will become 3. Second equation by 2. 2, so this will still become 6. Then multiplied by this by 2, so 4. Okay. Now instead of adding, subtract them. Okay, something from linear equations elimination. So this becomes 3y minus 2y dash. Remember, they are not, this is not y dash is equal to, this cancels and this becomes actually 7b e raised to power minus 2x. Put the value here, 3y minus 2y dash upon 7 is b e raised to power minus 2x. Okay, something is incorrect or still correct. B is coming also 5. How? You solved this correctly, na? 3. Oh my god, I copied the equation wrong. This was a and b, na? This was the original equation. So all I needed was multiply this by 3, 3, 3 and that's it. So this would have been 5. So this is 5. This is 5. Okay. Now I got the value of a e raised to power bx 3x and b e raised to power minus 2x. I'm going to put the value, let's call this as 3, let's call this, sorry, 3 is already used, so let's use this as 4 and 5. I'm going to put this in the third equation. Okay, so y double dash is equal to 9, a raised to power 3x will be replaced by 2y plus y dash upon 5 plus 4b e raised to power minus 2x is 3y minus 2y dash upon 5. Okay, and now both a and b are being eliminated. So kind of a unique idea, I'll say. Very different from the ones that we have already practiced. You can take the LCM and solve this. This becomes 18y plus 12y, so 30y minus 9y dash 12y dash minus 3y dash upon 5. Sorry, 9 minus 4 2, 8. Is it correct? 2y plus y dash. 9 minus. This is also wrong. This is not 2y. This was y, no? Now it's correct. So 9 minus 4, 5 upon 5. So basically y double dash is 6y minus y dash. That's your equation. So yes, very different idea, very unique in a way. All right. Next question. Y is a y is equal to e raised to power 2x a plus bx. So again arbitrary constants. 2. So 2 times you have to differentiate. Let's differentiate one time. So y dash is equal to e raised to power 2x. A differentiation is 0, bx differentiation is b. And how to eliminate this b again? Get this y dash upon e raised to power 2x is equal to b and differentiate again. Okay. How we are going to do that? We'll be using this a by b. Oh, u by b, I mean, sorry. So slightly weird expression, but yes, let's go for it. uv. Okay. So denominator is v square, so e raised to power 2x whole square. Numerator is u dash v, so y dash dash e raised to power 2x minus v dash e raised to power 2x differentiation into u is y dash is equal to 0. Okay. So denominator we can take it to the other side. So equation becomes y double dash e raised to power 2x minus e raised to power 2x differentiation is e raised to power 2x into y dash is equal to 0. Okay. Oh shit. My bad. This first step itself is wrong. Why was the first step was wrong? Because I forgot to apply uv in that. Okay. I cannot say that e raised to power 2x is a constant. No? I differentiated only a and this. So x is present here also, here also. This is uv from the start. Okay. Yeah. So let's differentiate. So dy by dx or y dash e raised to power 2x differentiation is e raised to power 2x into 2 a plus bx as it is plus this time a plus bx differentiation, so 1 a square, a differentiation is 0 plus b and e raised to power 2x as it is. So you can take e raised to power 2x as constant, and this is 2a plus 2bx plus b. Okay. All right. Now I can differentiate it again, but same problem will come. Even if I still differentiate this directly without doing any manipulation, we'll still apply uv, still a and b will exist. So we need to somehow manipulate this equation. Okay. So what should we do? We can have to reduce this. A lot of terms are there, no? A is also there, B is also there. We have to reduce this. So okay, good thing. You look at this thing. 2a and 2bx, a and bx. This is like double of it. So what I'll do is I'll write this as e raised to power 2x into 2a plus 2bx plus b into e raised to power 2x. Now take 2 also common, e raised to power 2x. Oh wow, that we could have done earlier also. Why did we solve it anyway? This whole thing e raised to power 2x a plus bx was from the beginning, it was y now. So we could have directly written y dash is equal to 2y plus b into e raised to power 2x. So y dash minus 2y, and take this e raised to power 2x also in the denominator, is equal to b, and now you apply u by v. Okay. So it was there already. Now let's apply u by v. So e raised to power 2x whole square. Okay, we are using u by v. Be very careful, u numerator differentiation, u dash. So y dash minus 2y whole dash. Okay, let's write it first and then we'll differentiate. E raised to power 2x as it is minus e raised to power 2x differentiation and y dash minus 2y as it is equal to 0. Take this denominator on the other side, that becomes 0. Now let's differentiate. This is y dash differentiation is y double dash minus y differentiation is y dash e raised to power 2x. E raised to power 2x differentiation is 2 into e raised to power 2x. Okay, minus y dash minus 2y is equal to 0. Take e raised to power 2x common. We got y double dash minus 2y dash minus minus 2 into y dash minus 2y equal to 0. So e raised to power 2x into y double dash minus 2y dash minus 2y dash plus 4y equal to 0. This is in multiplication now, so you can take this also on the other side because this is the main differential part. So you get y double dash minus 4y dash plus 4y equal to 0. Okay. So each question has slightly different ideas. Each question you'll learn a different approach. We have seen now that if you can separate constant alone, differentiation becomes 0 and we get differential equation from it directly. Okay, but how to get it, sometimes we have to see how can we manipulate the results. It's not like the arbitrary constants are 2, so you differentiate blindly 2 times and you'll get the answer. No. Okay. All right, last question. Last question is this, y is equal to e raised to power x a cos x plus b sin x. So again, 2 constants arbitrary, 2 times we have to differentiate to get the equation, but be smart about it. Let's see. Y is equal to differentiated 1 time, and be very careful, this was u and this was v. Okay, it's not like keep it as it is and differentiate inside. Okay, so u dash v, so e raised to power differentiation is e raised to power x. Okay, and this a cos x plus b sin x as it is, plus this time e raised to power x as it is, and differentiation of a cos x and b sin x. So minus a sin x plus b cos x. Okay. A cos this whole expression is y. You can see this is same, so I can say this is y dash. Now y dash we have differentiated, so y dash is y plus e raised to power x minus a sin x plus b cos x. So I can say y dash minus y is e raised to power x minus a sin x plus b cos x. Okay. All right, then differentiate again. So y dash minus y is e raised to power x. Okay, again we have to differentiate, and so we have to apply uv again. So e raised to power x differentiation, e raised to power x, b as it is, a sin x b cos x, plus e raised to power x as it is this time, differentiation of this, so minus a cos x minus b sin x. Okay, lot of terms. Again, if you look at this expression, isn't this the same one? So I can replace this as y dash minus y, but that would cancel it exactly, would it? Maybe, maybe not. This is same. Then y dash will cancel, y also that get cancels. It will not work. Yes, we missed something. I had to differentiate this. So that means this is y double dash minus y dash. Now it's okay. What about this? This is not matching with anything, so let's take negative even common, minus, if we take common, e raised to power x, a cos x plus b sin x. Okay, and now you see this was the same expression y, so let's remove that also. Y double dash minus y dash is equal to y dash minus y minus y. This was y, no? Okay, so get everything on the left side. I think that will be simple way. Y double dash minus y dash minus y dash minus 2y dash minus y 2y plus 2y equal to 0. That's your differential equation. Okay, all right, we got the equation. Family of circles we have done, parabola also done, ellipse also done, hyperbola. Let's do hyperbola, no? Hyperbola we haven't done, no? Interestingly, the idea is exactly the same, so I'll not be solving the whole question as such. I'll not be requiring to solve because I've already done it for ellipse, so I'll show you pretty much the same results. Okay, it's just that I want to discuss hyperbola, so that it's a quick revision again for that. Now, equation of hyperbola with the focus on x-axis. Hyperbola looks like something like this. Even if you don't know, you should know the equation. It looks like this on x-axis, and the equation on x-axis is x square by a square minus y square by b square equal to 1. Again, arbitrary constants. 2. Differentiate it one time. Okay, so differentiate 2x upon a square minus 2y y dash by b square is equal to 0. Take this on the other side. 2x by a square is equal to 2y y dash by b square. 2 cancels. Take this b here, x here. So b square by a square is equal to y dash by x. And now differentiate again, and we have seen this differentiation one time. We have solved it. Second, I think we used it. Where did I used it? Here. Here it was, no? Ideas was this, at least y dash upon x, na? This was already here, so same equation will be created here also. Pretty much the same, I think. The only difference is instead of minus a here, as such we have a b square by a square. But the point is the constant differentiation is always 0, and still you have to do the same thing over again and you'll get the same quadratic, same differential equation. Okay. This is hyperbola. The equation is still x by y double dash minus xy plus xy y dash minus y dash. All right. Circles, we have one more question. This time what they can do is they can only put special conditions on circle and you have to create equation accordingly, like we did in the questions in some examples that we covered. Okay, so we have to write equation of circle. First of all, let's create the equation. Differential equation of family of circles, center on y-axis. So center should be on y-axis, something like that, and radius is saying 3, so it means it can be anywhere. It's not necessarily it should be touching x-axis. Y-axis, x-axis, center on y-axis, so 0 comma some k. Okay, 0 comma k, and of course we don't know the radius, but I think the radius is given. Radius is given 3, so fine, radius is 3. So what will be the equation of this? X minus h square plus y minus k square, general equation, is equal to r square. Radius is 3, so 9, y minus k, h is 0 na, h comma k is the center, so x square. So you got yourself a single equation in this. Same idea, x square plus y square plus k square minus 2yk is equal to 9. Get all the constants on the right side. This one is alone constant, so get it on the right side, or you have only one arbitrary constant, so directly differentiate. Arbitrary constant is 1, so differentiate one time. So 2x plus 2y dash, k square differentiation will be 0, constant, minus 2y dash k is equal to 0. Get the value of k, put in this equation. This will be, this time it will be complicated slightly. Okay. 2. You can first of all eliminate this 2 by taking common. So this is x plus y dash. Take this on the other side, get the y dash in the denominator, upon y dash is equal to k, or if you want you can split it in two parts, x by y dash plus y is equal to k. Okay. Now replace this value of k in this equation, or if you want to, it depends on the option. If they have given maybe option like this will be much more simpler. Okay, replacing k from this will give you a standard equation, but again depends whether the question have given the answer in that form or not. Okay. X square they can create the equation. Let's solve few steps. K square 9, 2 times we have to solve then. There is a smart approach like this one. I'm not sure that you will get the answer, but this is going complicated. Reason being, k square, that will create a slight chaos. So what I do is, of course that is one approach, but what I can think of another one is, if we differentiate this directly, so 2x plus, using chain rule, so 2 into y minus k into y dash is equal to 0. The benefit of that, what I can see is, this y minus k can be directly replaced. Okay, so 2 cancels if you take it on the other side, taking common. So x upon x is equal to y minus k into y dash, take this y dash here, so x upon y dash is equal to y minus k. And what you can do is, you can replace y minus k in this equation. That will be much easier. X square plus x by y dash whole square is equal to 9. Okay, so you can write x square plus x square by y dash whole square is equal to 9. Take the LCM, y dash square x square plus x square is equal to 9 y dash whole square. Solve it any further, should be, you can get this y dash on same side also. I want to generate y dash this time. Again, this could be the answer. Again, I'm giving you possible options, like what could be generated. Okay, depends whether they have generated in that form or not. This could be the answer, or if we take this on the other side, y dash square x square minus 9 y dash square, okay, plus x square equals to 0. So if I take y dash, sorry, 9 y dash, I've written whole square, my mistake. This is 9 y dash. One second. This is that was 9 y dash whole square, 9 y dash square, 9 y dash square. So y dash square, if I take common, I get x square minus 9 plus x square equal to 0. You can generate y dash square or y dash from it. This could be the answer, or y dash square is equal to, take this x square on the other side, write down x square minus 9 in division also. Okay, so again, depends how they have presented the answer. I can generate like this also, or this is also a way to represent the answer. Okay, both are correct. Answer, this is also answer, this could also be the answer. Alright, done with this concept. We have learned now how to create a differential equation. Okay, of course after this we'll learn how to solve a differential equation. Okay. So that's it for this class. See you in the next class. Good day everyone.